Today we are going way, way back to basics. But I'm not just talking about any basics. We're talking about the fundamental logic that pretty much underpins our entire reality. From, your grocery bill all the way up to the orbits of the planets. These are the simple but incredibly powerful rules that govern everything. So let me ask you a huge question. How do you build a universe? It seems impossibly complex, right? Where would you even begin? With particles, energy, the laws of physics? Well, what if I told you that the instruction manual for reality, its actual source code, is a lot simpler than you might think? That's it, right there. You just start with 4 fundamental concepts: addition, subtraction, multiplication, and division. And look, these aren't just some random operations you had to learn in school. They are the essential actions that describe how our universe assembles and, disassembles itself. Okay, so let's start with the very first, the most primal idea: addition. This is the act of creation, really. It's all about combination, about making more from what you already have. Just think about it for a second. A star forming from a giant cloud of dust and gas, that's just addition on a cosmic scale. A company growing its assets, that's addition too. It's literally the engine of accumulation, the principle that allows things to become greater than they were before. And at its very core, it is just beautifully, elegantly simple. 3 plus 4 equals 7. It's a pure, simple truth. And it's the bedrock that everything else we're going to talk about is built on. And now, of course, we have to look at the other side of the coin. Because for every act of putting things together, there has to be an act of taking them apart. And that is subtraction. It's the force of reduction, of finding the difference. And right here, you can really see their relationship so clearly. If addition is all about creating a bigger whole, subtraction is about taking that whole apart to see what's left over. They are perfect inverses of each other. Just this beautiful symmetry in the language of numbers. One can't really exist without the other. Now, the crucial point here is that subtraction isn't just some new rule. It's basically the undo button for addition. It lets us measure distance or loss or just what remains. It gives us this incredible ability to compare, to analyze, and to really understand change. So once you've mastered combining and separating, you start to see the limits, right? What happens when you need to combine things on a massive scale? Well, that's where our third idea comes in: multiplication. Isn't some totally new concept. It's really just addition, but supercharged. Just imagine you've got, say, 4 groups of 5 apples. Now, you could add them up one by one, but that feels, slow and clumsy, doesn't it? Our brains are always looking for a better, a faster way to do things. You could do it this way. 5 plus 5 is 10, plus another 5 is 15, plus that last 5 is 20. Yeah, it works for sure. But look at all those steps. There has to be a more elegant solution. And boom, here it is. The power of this is just how simple it is. In one clean, concise statement, we've done the exact same thing. 4 times 5 is 20. This is the leap from just simple counting to really powerful calculation. Multiplication is the language of exponential growth. It describes how things scale up, from a single cell that divides and redivides to become a living thing, to the interest compounding in your bank account. It's addition, but it's been turbocharged for efficiency. And finally, just like subtraction is the undo for addition, our last operation undoes multiplication. So if multiplication is all about scaling things up, division is about breaking them down into equal, fair shares. Yeah, division is really all about fairness and distribution. It allows us to answer really important questions like, how can we split this up evenly? It's the principle behind everything from cutting a pizza for your friends to calculating an average score. And it's so simple, really. If you have 12 of something, cookies, dollars, whatever, and you need to distribute them among 4 groups, division tells you, cleanly, that each group gets a fair share of 3. It's the great equalizer of mathematics. So, we've just looked at 4 separate ideas. But the real magic, the real aha moment, happens when you stop seeing them as 4 different rules, and you start seeing them as one single, elegant, and interconnected system. This gives us the whole picture. You have 2 primary actions, combining and separating. And then you have 2 levels, the foundational level with addition and subtraction, and the amplified or scaled up level with multiplication and division. This isn't just some neat little table. This is the logical kernel that allows for all of higher math, for algebra, for calculus. It's even the root of the binary logic that's inside every single computer, just a constant process of adding and subtracting ones and zeros. So, the crucial takeaway here is this. These four operations are so much more than just arithmetic. They are a logical framework for understanding the entire world. They are the simple rules that, when you combine them, allow for literally infinite complexity. It really makes you wonder, doesn't it? If these four simple ideas can build the entire universe of math and logic, what other foundational principles are out there, hiding in plain sight, just waiting for us to stop and appreciate their profound universe-building power?